Now, a ship X is located 40 kilometers due west of another ship Y, which is heading due south at a speed of 10 kilometers an hour. If the speed of ship X is 7 kilometers an hour, in what direction should X head to get as close as possible to Y? Okay, X and Y, one located 50 kilometers west of the other one. Okay, phi Y is heading directly down, and phi X doesn't know where to go. It's probably going to head somewhere around this way, isn't it, to try and intercept it. Now, here's your 50 kilometers here. Now, unlike previous questions, we're going to choose which one to fix to the spot. I'm going to fix Y to the spot. No reason, you can fix either one of them to the spot. I'm going to write down phi xy equals phi x minus phi y. And then I'm going to do what I usually do. We're going to get phi x on its own equals phi xy plus phi y. Now, upon completion of that, I'll do my table. 1 and 2, magnitude and direction. Okay, and now once I've done this, okay, what we're going to do next is we're going to basically what I'm going to do is I'm going to fill in my speeds. Okay, so I'm going to need the question to do this. So, what is the magnitude of x? Speed is 10. What is the magnitude of y? Oh, sorry. 7 and 10. I got them mixed up, didn't I? 7 and 10. What way is phi y going? Is that everything I have? Okay, that's everything I got. 3 out of 6. Okay? When you have 3 out of 6, you're going to have a sine rule with 2 variables.
Is the x, y going west?
You don't know, because it can't go west because it can't intercept it. If it was an interception question, it would definitely be travelling east. But it's not fast enough to make this happen. So it's not going to be able to go straight across to y. So the relative direction of phi xy cannot go straight across to y, because it's not an interception question, it's a close as possible question. Okay, so the bottom line is y is going down 10 every hour. Y is going down 10. X at best can go down 7. It's always going to be losing ground upwards. When you drive x's 7 across, you're reducing the ij component even more. So this means that the velocity of x relative to y can go in one direction only. Do you know what direction that is? It has to go this way. It's going to be falling away from y. Okay? In fact, it might not be going. It might be getting further away from y. If anything, it's hard to know. Okay? So, what can we do to sort this out? Okay, so here's what we're going to do. We're going to choose a direction that we know for sure. What direction do we know for sure? We know phi y, yeah? And we can be guaranteed that phi y is the biggest line in the diagram. How do I know that? Okay, if somebody's moving 20 meters per second and I chase them, and I'm going slower than the person I'm chasing, which is 5. The 20 is bigger than my 5, and the 20 is also bigger than the 15 relative velocity. That's how I know it's going to be the biggest line in the full thing. Okay? So, therefore, what I'm going to do is I'm going to draw this y value going directly down at 10, directly south. Okay? And here it is here. Now, if this is the case, I started off my value here. This is where I started off. I have to pair off phi y and phi x from the same starting point, don't I? Now which way did we say phi x should go? It's not going to go this direction, is it? Because you're chasing phi y downwards. So if anything, you're going to go diagonal right down. So diagonal right down for phi, what's it, phi x, isn't it? And then, so that's phi x, that's phi y, and this here is going to be, now which one? Phi x equals phi xy plus phi y. So phi x equals this one plus this one. Okay, current triangle law. Now fill in our numbers. We got 10, we got the fact it's going south, and we got the number 7. And I think that is all I might have. You know, that isn't great, is it? It's not great at all. But look at this. You always have to go opposite. You always have to go opposite your information, don't you, for the sine rule? So look at this. Sine A. Oh, sorry. Sine A over 10 equals sine B over 7. Now when this happens to you guys, okay, what you're always going to do is you're always going to make one of the sines 90 degrees. It's always going to happen in these 3 information questions, and you got to decide which one. Now, what happens if you move the 10 up here? 10 over 7 sine B, and you make B 90 degrees. What happens then? You get 10 over 7, and you can't sine inverse 10 over 7, so that's impossible. Okay? So what you're going to do instead is you're going to bring the 7 up here, and you're going to say 7 over 10 sine A equals sine B. Now, let me show you. What does B represent, guys? See B. If you want B to be as large as possible, what do you need from sine A? You want sine A to be a value of 1. So, when A equals 90 degrees, sine A equals 1. It gives the largest possible value of this part here, which in turn will give the largest possible value of B. Now why do we want the largest possible value of B? The bigger B is, the more flat it's going to go. So go back to your original one. The bigger B is, now B is represented by this angle in here. Does everybody understand? B is this angle here. And the bigger B goes, the flatter the motion x relative to y is, and the closer it will get to position y in its subsequent motion. Okay? So what we're going to say here is that let A equals 90 degrees, so therefore 7 over 10 equals sine B. B therefore is sine inverse 7 over 10. What is sine inverse 7 over 10? Can anybody tell me? Sine inverse 7 over 10?
44.43.
44.43. Now look at this. We've now decided that this here, just gonna rub out this one and this one. We said that A is 90. We said that B is 40.43. What does that make the top angle then? (180 minus 90 minus 44.43). 45.57. Now look at this, guys. We're asked for the direction X should head. It's heading south, 45.57 degrees east. There you go. Now, what is the shortest possible distance between the two ships? Go back to your original diagram. Now, what do we know about... We know that this angle here, see the phi x angle? We know that the phi x angle is 44.43 to the vertical. So we know, if I rub all this out again, we know that that's x and y. That's 50 there. And what we know about this is that it's travelling at this angle in here was, you gave it to me earlier, it's 44 points. Was it? 44.43, which in turn makes this angle here 45.57, and this here travels along until it hits at 90 degrees, which is going to be this part here. Yeah? And the question wants us to find the shortest distance between the two ships. It's going to be this length here to this length here, which is going to be sine. So sine 45.57 equals d over 50. And d is going to equal 50 sine 45.57, and what do we get?
35.7.
Sorry?
35.7.
35.7 kilometers. Okay. Now, a ship Q is located 100 kilometers northeast of another ship P. Q is sailing at 8 kilometers in the direction due west. The maximum speed of P is 3 kilometers an hour. Find the direction of P as it wishes to come as close as possible to Q. We're definitely, because it's not an intercept question, we're definitely dealing with 3 pieces of information out of 4. Okay, so what we're going to do is just draw an initial diagram. Northeast, so sorry, northeast is positive, excuse me. So just going to alter this here. There we go, northeast. Okay, now of ship P, so that's Q, that's P, and that's 100 kilometers. Okay, and that's not too bad. Now, what we also know about this is that Q is sailing 8 kilometers westerly. Now, it has to be sailing back in towards it, otherwise the start of the question is going to be the closest distance. Yeah? So that's why it has to be sailing back in towards P. Now, the next thing is that P is going at 3 kilometers an hour. So we'll imagine P is going to try and cut upwards somewhere, okay? So we're imagining that phi P is going this direction. We're imagining that phi Q is going this direction at 8. And what do you think about the subsequent motion? Phi P minus phi Q, where do you think that should go? Phi P can never match phi Q's direction to the left. Do you understand? So if we do phi P Q, what was it? Yeah, we'll do phi P Q. The velocity of P relative to Q. Going to keep Q stationary. Okay? What can we say is guaranteed to happen every time? Q is going to be pulling further and further left in comparison to P. Because Q can go 8 across, and if P was to put all his effort into going across, it could go only 3. So that means Q is going to pull out a gap of 5 from left to right every hour. This means automatically that the velocity of P relative to Q must be going in the right direction. And because we're moving up, we're closing it in going upwards, aren't we?
Yeah.
So it's going to be diagonal, right, up. Happy enough with that? Now, let's construct an equation and let's try and construct a triangle from this. Phi P minus Phi Q. Do what we did last time. Phi P equals Phi PQ plus Phi Q. Assemble your table. And what we're going to get is magnitude and direction, or speed and direction. Now, speed of P. Anybody speed of P? 3. Speed of Q. 8. Velocity of Q, or direction of Q. West. 1, 2, 3. 3 pieces of information only. Okay, let's go back to the top here. Now, look at this part. Let's start off with Phi P and Phi Q. We're going to use these two lines as our start off point. Okay? Phi Q is going to be the largest line in the diagram. How do I know Phi Q is going to be the largest line? Because once again, it's the fastest boat, and if you're chasing it, your relative velocity is going to be slower than 8. Okay, so we know it's the largest line, okay? So this represents Phi Q. What did we say about Phi P? Has to go up in this direction here to try and intercept it. That's Phi P. And remember, if I take this one here, which is represented by the blue line must equal the other two lines added together, the same displacement. So basically what we're going to get is we're going to get this triangle here, basically like this. And what I'll do is I'll just make sure we have an actual triangle. So here's what we're looking at. Now, technically the triangle has a problem with it, doesn't it? Phi Q should be the longest side, shouldn't it? So if that's the case, then it should obviously be folding back inside. So either way, the diagram will fix it. Okay? So what we're going to say is Phi Q is the largest side in the diagram. Phi P, we initially thought it's going diagonal up. Now it might be going diagonal up and left. Bottom line is, if I'm wrong, what will this angle be if I'm wrong? It'll be an angle bigger than 90 degrees, and it will bend itself back into the correct position according to trigonometry, okay? So we don't have to worry about that too much. And what about this one here? Phi PQ. Let's assemble information. What two sides do we know the value of? We know that this here is 8, and this one here is 3. We'll call this angle A and call this one angle B. Now, angle A and angle B. Now look at this. Sine A over 3 equals sine B over 8. Now remember what I said last time. What I do in the test, or what I remember from these questions, is if I move the 3 up, I get 3/8. I can sine inverse 3/8. That's grand. If I move the 8 up, I can't sine inverse 8 over 3. So that automatically tells me, without really even understanding the question, which one I actually have to bring up. So it's going to be sine A equals 3 over 8 sine B. This automatically means to me that I need to make sine B what? Anybody remember? Sine B should be as large as possible. So sine B equals 1, B therefore equals 90. Now let me explain the logic in this. If we make B as large as possible, okay, so we make B 90 degrees, okay? So by making B 90 degrees, what effect does that have on A? It makes A the largest value of A it can possibly be. Do you understand? If B was any other number other than 90 degrees, we'd then get a smaller value for angle A. Because if you sine inverse an eighth, it's a much smaller angle than sine inverse in 3/8. Okay. Now this means that we've now in effect made angle A much bigger, and the bigger angle A is, what does that mean? The bigger angle A is, the closer it's going to get to its position up to B. Because remember, B is located at how many degrees? Northeast. Okay, so if you remember, oh sorry, not B, Q. Q is located 45 degrees. Yeah, upwards. And we would ideally like P to be able to travel all the way up and collide with Q. But that doesn't happen, does it? Because it's not fast enough. So currently speaking, our angle, and this is the velocity of P relative to Q, is represented by this green line here. The bigger this green line is, the closer it'll actually get to Q. So that's the visual representation of what's going on. So what does this mean about sine A then? Sine A is what angle?
22.024.
Sine inverse 3/8, which is, was it?
22.024.
0.24, let's call it 22.02. Okay, so A is 22.02. Okay, and then what does that mean for phi P? 180 minus 90 minus 22.02.
67.98.
67.98. And that means it's going to be travelling, do we have to find out which direction P is travelling in? P, yep. It's going to be east, west, 67.98 degrees, north. Happy enough with that? And then we eventually have to find out find the nearest P can come to Q. Now, here's an interesting way of doing this, okay? Now we have all our information below, and what we know is that this here is 100, and that's 100, yeah? And that's located at 45 degrees, correct? Now, I'm now going to do the direction of P relative to Q. P relative to Q goes 22.02 degrees from the flat part, yeah? So it goes 22.02 degrees upwards, up 22.02. Around there. There's Q. There's P. There's the, the 90 degrees, isn't it? So it has to go up at 90 degrees. Oh, sorry. That. Okay. So it has to go, there's Q, there's P, and this here is the motion of P relative to Q, hits the shortest distance. Okay. Now what is this angle in here? It's 45 degrees minus 22 degrees 0.02, and what do we get there? 22.98. Let's calculate distance D. Sine 22.98 equals D over 100, and D therefore is 100 sine 22.98, and what do we get?
39.04.
39.04 meters.